Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at what's typical, sampling distributions, and simulation. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our two panelists for tonight, Landy Godbold and Gloria Barrett. Landy holds a bachelor's and master's degrees in applied mathematics from Georgia Tech and retired after 40 years of teaching mathematics at the Westminster Schools in Atlanta, Georgia. He introduced statistics as an elective course early in his tenure there and has actively promoted the teaching of statistics since his participation in the Woodrow Wilson Summer Mathematics Institute, which focused on statistics in 1984. He continues to look for new ways to use technology to help students understand subtle statistical concepts. Landy, thanks so much for being with us tonight.
Great to be here.
And recently retired from the classroom, Gloria taught secondary mathematics for 30 years, most of them at the North Carolina School of Science and Mathematics in Durham, North Carolina. She's received a T-Cube National Instructor and College Board Consultant for many years, and Gloria has conducted numerous workshops for teachers, both nationally and internationally, focused primarily on mathematical modeling and strategies for teaching statistical concepts using the TI-Nspire calculator. Gloria, thanks for being with us tonight.
Thank you for having me.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send questions to Gloria or Landy using the Q&A window on the right side of your screen. We'll also use the chat window to send general messages. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, find your name in the participant window, and in that same window there will be an icon that looks like a telephone. By clicking that icon, you'll receive call-in information, and that call-in information will let you change your audio to using a telephone. At this point, Gloria is going to discuss our agenda.
Okay, well, welcome everyone. The overarching theme of tonight's session is why do we need sampling distributions? And we're planning to do two activities. Both of them are based on AP statistics free response problems that will help answer the question of why do we need sampling distributions. The first example is based on categorical data. It was on the AP Statistics 2005 exam, problem number 4. If any of you are AP statistics teachers, you might recall this problem was the one that dealt with cereal vouchers. And we're going to work through the problem primarily using TI-84 Prob Sim app. The second example is based on numerical data and the AP Statistics 2009 Form B, problem number 5. And we will work through this problem primarily using TI-Nspire. As time allows, we are hoping to show at the end of each of the examples how you could set up the simulation that we are using with the other technology. So when I do the TI-84 problem, Landy will follow up and address how you could do that with TI-Nspire. And then after Landy goes through the problem with TI-Nspire, I'll come back and talk about doing that with TI-84. As time permits, Mike will spend a little time at the end talking about online resources, and then we're definitely going to allow time so that we can announce the winner of I'm sure this is a randomly selected registration winner for registration for the T-Cubed International Conference, which is in San Antonio in March.
Gloria, thanks so much. And Gloria, also, if you wouldn't mind sharing some of those expected outcomes for tonight.
Okay. So the expected outcomes are in two categories. The first deals with statistical concepts. And as you can see, we have highlighted three concepts. The first is that hypothesis tests embody the what's typical logic. The second is that identifying what's typical requires a distribution that allows comparison of what's possible to what has actually occurred. And the third, sampling distributions are integrally connected to the hypothesis being tested. The second set of outcomes will deal with technology skills. Essentially, we want to design simulations to generate reference distributions for given hypothesis test scenarios. We are going to implement simulations using TI-84 tools such as ProbSimApp and RandNorm, or TI-Nspire tools such as RandNorm and Capture. And then we're going to make hypothesis test decisions using the simulated reference distributions.
Thanks, Gloria. It looks like we have a lot to do tonight, so Landy, you have control. Feel free to share your screen.
All righty. You said we have 2 hours for this, is that right?
Yep, 2 hours minus 1 hour. Yep.
Okay. I wanted to make one quick comment, especially for the AP teachers in the group, about some of the language that's on the outcomes side that Gloria just talked about. On the previous slide, in the upper section, you'll see the expression sampling distributions, and in the lower section, you'll see we call them reference distributions. In the last few years, the AP rubrics have been fairly picky about calling something a sample when it's not a sample. So think about experiments, and this was something that, for example, was talked about in the, I believe, the second webinar that Jeff and Diane did, that when you get data from an experiment, there may not, in fact, have been a random sampling process. So calling that a sampling distribution isn't quite correct. What we're going to be doing tonight really is going to focus on the sampling situation, but the language of sampling distributions and reference distributions is something that may be something you encounter as you go further along. So in the previous webinars that we've had, Gail and Robin talked about graphical displays of data, so how to see what's typical. The design and that Jeff and Diane did talked a lot about how to minimize the spread in what's typical. Tracy and Don in the probability unit talked about how to measure variation in what's typical. And everything here we're talking about is about variability. So each of these things have been looked at. What we're going to talk about tonight really is how do we use those ideas of seeing, minimizing, measuring variability within a distribution. And so that's what we're going to be looking at is sampling distributions and why we need them and how we get them. So to put this in some sort of context, as a quick example, we won't work through, but to establish the questions that we're going to be dealing with, this is from the 2006 Form B free response question. It was number 6 question, actually. And the central idea was that Sunshine Informants wanted to know whether there's a difference among the consumers in their preferences for new products. And they did a blind taste test with 6 of 8 of the respondents picking tropical taste over citrus fresh. And so the questions that we want to figure out there is, do the taste results provide any evidence to support the existence of a difference? If you go back, is there any evidence to support the existence of a difference? Well, yeah, sure. 6 out of 8 preferred one particular flavor. 6 out of 8 is not 50%, so yeah, there's a difference, at least in the group that we looked at. but do those results provide convincing evidence to support the existence of a difference among all the consumers? I don't know. How do we figure that out? So that's really what tonight's about. And what we've got to decide is whether that 6 out of 8 is typical of sort of the world in which there really is no difference. So the null hypothesis, in this case, the fact that there's no difference between the preferences, defines a world. It's a hypothetical population, and then we actually collect a sample from the real world, measure some statistic in that real world, and then we have to decide whether that statistic that we've looked at, that's what we've observed, is typical of the hypothetical world in which the null hypothesis is true. So in a sense, what we're looking at here is the comparison of some evidence versus convincing evidence. We're looking at what I like to call in my class is what did happen to what should happen. The what did happen is the sample statistic from the real world. We've observed the value of it. We have that in our hand. What should happen is what should happen in the world of random sampling from the hypothetical world that we talked about. And so we've got to look at how the statistic that we observed behaves in that hypothetical world. So we've got to be looking at the right statistic and in the right world. So our question then really is, where does all that come from? The sampling distributions are what allow us to visualize the sample values that are typical under the conditions of the world in which we're working. So the short answer, where do sampling distributions come from? The short answer is they come from the null hypothesis. The null hypothesis tells us the world in which that sampling distribution comes from, but then where does that distribution, how do we figure out its properties? And there's two ways. One is theory, so you can talk about normals, t-distributions, chi-squares, f's, whatever, or you can use simulation. Tonight's focus is going to be on simulation. And I think with that, I will let Gloria talk to us about a problem in depth. Okay. So, Gloria, I think you have it.
All right. So let's see if I can get my screen up. Okay. So hopefully you are seeing a statement of the 2005 AP Statistics exam, problem number 4. And I am going to read this as you read along with me, hopefully not too fast. It stated that some boxes of a certain brand of cereal include a voucher for a free video rental inside the box. The company that makes the cereal claims that a voucher can be found in 20% of the boxes. However, based on their experiences eating the cereal at home, a group of students believes that the proportion of boxes with vouchers is less than 0.2. This group of students purchased 65 boxes of the cereal to investigate the company's claim. The students found a total of 11 vouchers for free video rentals in the 65 boxes. Suppose it is reasonable to assume that the 65 boxes purchased by the students are a random sample of all boxes of the cereal. Based on this sample, is there support for the students' belief that the proportion of boxes with vouchers is less than 0.2? So when this problem showed up on the AP Statistics exam, the expectation was that students would do a formal one proportion z-test. But we don't want to go there. We want to think about how we can answer this question at an introductory level without performing a formal significance test. And to get started with that, we've kind of got to go through and think about some of those things that Landy was just mentioning. We've got to think about the hypothetical world versus what we've observed with the sample. So I've got a few questions that I would like to pose for you folks to think about, and I'm hoping for the first 2 or 3 that they're short enough that you can maybe give responses in the chat window. Landy's going to monitor that for me. And the first question is, what is the parameter of interest in this question? So if we look back, what is the parameter of interest?
Don't be bashful. Okay, we have % of boxes with vouchers, the true proportion of serial boxes that have the voucher, percentage of the boxes below 20%, a proportion of boxes with vouchers. It looks like proportions of boxes with vouchers seems to be popular.
Yes, and it is the proportion of boxes with vouchers, but to make it from looking at it from the perspective of the parameter, it's the proportion of boxes with vouchers in the entire population. Serial manufacturer claims that that proportion is 0.2. Okay, so what would the null hypothesis claim about this parameters world? And I think I just answered that myself. What would the null hypothesis claim about the proportion of boxes with vouchers in the population? Okay, I'm seeing P equals 0.2, P being the population proportion, and that's exactly right. That is the world that we are, exactly. And we can do that formally, or we can just think through that that's the world that, the hypothetical world that we're starting with. What's the value of the statistic here? What's the value of the statistic that measures the sample proportion? And unless you have the problem memorized, we probably need to back out to here. Okay, 11 vouchers in the sample of 65. I see 11 over 65. And to get back over here again, if you put that into a calculator and compute it out, we get a sample value of about 0.17. So population proportion of 0.2 is the hypothetical world. The real world, what we found was 0.17. So again, we asked the question, do the sample results provide any evidence to support the student's belief? What do you think? Do we have some evidence to support the student's belief that the true proportion is less than 0.2? I'm not seeing any answers to that. What do you think? I think we do. I think we have some evidence because what we got was 0.7, which is less than 0.2. If the students had found 20 boxes in their sample of size 65 with vouchers, then they would not have had any evidence at all. In fact, they would have gotten greater than 20%. So yes, because the proportion they got is less than 0.2, there is some evidence to support their belief. But the bigger question, do the sample results provide convincing evidence to support the student's belief?
Hey, Gloria.
Yes.
I apologize for interrupting. We had a question from Gary. He wanted to know if the sample was too small.
As in sample size 65? No, the sample is not too small. 65, and again, we're doing this in a very informal look at this, so we're not concerned about conditions required for formal significance testing. But even in the formal significance testing, a sample size of 65 would be fine. I'm not sure whether Gary is thinking about it as like an AP statistics teacher, but I'll go off on that tangent for just a minute and say that the the large sample condition here is that n times p and n times 1 minus p are both greater than or equal to 10. And in this case, our numbers are, if you did 65 times 0.2, we would get 13. And so we are greater than or equal to 10.
Gail, not Gail, Gloria, can I interrupt for just a second?
Sure, yeah.
And remind everyone that the conditions that you just mentioned for the formal test is going back to the other way of doing inference, that is by using theory. And the theory, starts with a binomial distribution and approximates it with a normal. So that's where all the baggage of that particular calculation comes in, of sample size, what's a big enough sample size or not. If using simulation, then you really free yourself of that particular baggage. You still have to meet the null hypothesis.
Exactly, and I think one of the things that we spend a lot of time talking with students about in statistics classes is, it would be wonderful if we could have really big samples for all of our investigations, but sometimes we just don't have that. Money and time do not allow. So in this particular case, 65 boxes, a random sample of 65 boxes should give them pretty good information, I think. So moving forward, and not worrying about any kind of underlying conditions here, let's look and see what we've got, what we have relative to what would be typical if, in fact, we do have the vouchers put in 20% of the boxes. So what I would like to do is to think about how we can use simulations to generate a distribution of values of sample proportions that would be typical. And by that we mean sample proportions that we would get in samples of size 65. That's all we got is 65. In the world where the population proportion is, in fact, 0.2. Okay? Simulations can give us distributions if we set them up correctly. So what I would like you to do is take a minute and think about how you could use a container of marbles to simulate the proportion of boxes containing vouchers that we would get in a sample of 65 boxes, assuming that the null hypothesis is true and the company is putting vouchers in 20% of the boxes. So look at that a minute and maybe think about it from the other direction. If the company really is putting vouchers in 20% of the boxes, how could we use a container of marbles to simulate the proportion of boxes that would contain vouchers in samples of 65? And Johnny says to scoop samples, and I would agree to do that, but where are we going to scoop them from? Colored marbles, yes, and this is going to be a more lengthy response than you're going to be able to give all the details of in the chat window. So Landy and I talked in advance and decided that maybe it would be good for Landy to just kind of outline this for us, and we'll listen in and see if there's if he leaves anything out or if we can follow what he says. So Landy, can you take that away for us here and tell us how you would use marbles?
I'll try, but as soon as Johnny said scoop, I'm thinking M&Ms now instead of marbles.
Well, you got to use marbles.
Why?
Please.
Okay. Well, let's see. Our world that we're trying to build has a true proportion of 20% of something. So I guess I need 2 colors of marbles, 20% of one color and 80% of another color. And that could be as small as 2 and 8, for example, or bunches more if I wanted to. But let's go with 2 and 8. And I will draw marbles out with replacements so that each time I look at a marble, the proportion of marbles hasn't changed on me. And I need to look at 65 marbles because that's the statistic, or that's the size of sample that you based your statistic on when you observed your 0.17. So I have to work with your world of 0.2 and your sample proportions of groups of 65. So pull 65 marbles one at a time out of a bucket that has 2 blues and 8 reds, and count and see how many reds I get. No, how many blues I get.
How many blues you get, right. Sounds like that would work. Ideally, what I would love would be to have many, 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 many marbles, maybe 1,000 marbles, and have 200 of them one color and 800 the other, and then not have to maybe take them out, and we could maybe take 65 and not have to worry so much about replacement. But you know, whatever you would need, you are going to need to replace unless you have a very, very, very big tub of marbles. And of course, we want to make sure they're all mixed together quite well. I do know some statistics classrooms where there are lots of nice little things around like marbles and beads where maybe you could set this up. And if you could, I really do believe that doing the hands-on simulation is a great experience for students. The good news for us is that technology can also do this, and most of us tonight, we're definitely pressed for time, and most of us have time problems even in our classrooms. So what I want to do is show you what I think is a really cool, efficient way to do pretty much what Landy just said using the probability simulation app, which is available for 83 plus, 84 plus, all the 84 plus C, CE, and can be downloaded from education.ti.com. So even though we're talking 84 tonight for the ProbSim app, if you're in a situation where your students are needing to use TI 83 pluses, they can do the ProbSim app with that as well. If you tuned in for the seminar that dealt with probability, this is the same app that Tracy Watson used, and I'm going to leave the PowerPoint and go to my TI-84 Smart View and show you how we can set the simulation up. Just so you'll know, Mike is going to have some resources available for download, and I have written up the instructions, the settings for the app simulation. You can get that later. You don't have to take lots of notes right now if you just want to follow along. As Tracy mentioned in the previous webinar, it is critically important that you reseed your calculator before you start doing any kind of simulations. Otherwise, everybody's going to be getting the same results. And ideally, what we want to do is we want to get the students doing these simulations and then pool the results to be able to get a distribution of sample proportions that might result from the scenario. So to reseed the calculator, what I ask my students to do is on the home screen, type in the last 4 digits of their cell phone number, and then you just need to store that personal number to RAND, and RAND is under Math Probability Option 1. When you press Enter, you get your number back, and I don't pretend to understand exactly what's going on behind the scenes. What I do know is that what I tell my students is it's sort of like I've just given you your own number, line number for a random digit table. You're starting at a different place than I'm starting. Okay. Once we do that, we can go to Apps and ProbSim, and you'll see when we go there that I have a seed option available in this version of the ProbSim app. I could have used that, but older versions I don't think all have that, so that's why I wanted to show you the seed option from the home screen. Okay, I'm going to go into the marble simulations because that's what I led you to think about and what Landy just explained. And when we get there, the marbles are preset to be 5 different types. I only want 2. I want 2 colors of marbles. So I'm going to need to do some setup, which I do by pressing the zoom key. The first line is trial set. I need 65 draws from my bag of marbles. I need 2 types of marbles. I'm going to get a graph, and I want that graph to show proportions because that's the world that I'm working in rather than counts. So that PROB stands for probability. I'm going to leave store table alone, clear table, yes. Definitely want to sample with replacement and update, have my graph move after each one. Now, if I pressed OK right now, I would have 2 types of marbles equally represented, 50-50. So to get 2 of the one and 8 of the other, I need to go into an advanced setting, and I could do 20 and 80. I will do, as Landy said, 2 and 8. Since we're sampling with replacement, it really doesn't matter as long as it's 20%, 80%. So what I'm doing is I'm loading my marble bag to represent the hypothetical world, the world where 20% of the boxes do have vouchers. I'll tell it OK and OK again. And yes, I'm OK with clearing memory. And now I will pick marbles. You can see up here I've got 65 with replacement. Not all versions will give you that information. But if you press the right arrow key, I can see that 25% of my marbles were blue marbles, representing or indicating that 25% of my 65 boxes had vouchers. Now, I'm trying to set up a distribution, so I have a graph that I'm going to start here. And I'll switch over and see if I can get the document camera to show you that. The label on the horizontal axis is simulated proportion of boxes with vouchers. And what I'm going to do is start a dot plot, and I would put a little X right here to go with the 0.25 that I just got from that simulation. Okay. I'm going to move back over and show you one more simulation, just so you'll know how to do another one easily. If I were to pick again right now, I would get 65 on top of the 65 I already have. So to redo this simulation, I need to go back into settings, and the only thing I need to change here is I need to go down to clear table and make sure I answer yes. And now when I press OK, and it asks me if I'm OK with clearing memory, which is exactly what I wanted to do, now I can do another simulation with a fresh start and arrow over, and this time I got 15% blue, representing 15% of the 65 boxes having vouchers. So back over to my graph, and now I would fill in 15%. Now, in a classroom setting, what I would do is go around and ask all the students to tell me what they got, and we would fill in 25 or 30 simulation results, and then we would do it again and again. And I will fast forward and show you what I got recently when I did 100, I think this was based on 110 simulations. See if I can zoom in a little bit. You can see that the sample proportions, these are simulated proportion of boxes with vouchers, they seem to center at about 0.2, which is what we would expect. My sample results were as low as 0.08 and as high as 0.32. Here is 0.17, which is what we saw in our sample of 65 boxes. And I think at this point, you're probably better equipped to answer the question, is 0.17 convincing evidence that the true proportion is less than what the serial manufacturer claims? If you count all of the samples, how many samples had 0.17 or less, I get 30 out of my 110 samples with 17% or even smaller proportion of vouchers. 30 out of 110 is about 0.27% of the simulations. I'm not convinced that the serial manufacturer is cheating us. I think 17% is not all that unusual a result from a sample of size 65. Okay. Landy, did I leave anything out there that I needed to mention?
Sounds good to me.
Were there any questions? I'm watching the clock and realizing that this took a little longer than it probably should have. Anything that we need to address before I turn things over to Landy?
I think we're good. Thanks, Gloria.
Okay. So let's see. I am going to pass control to Landy. All right.
Okay, while she's doing that, I would like to make one quick comment based on some of the things I saw go by in the chat window about sample size 65. Several of the comments were along the lines of, we need more evidence. One thing to remember is that in the formal inference realm, you really only get one sample. At the design stage, you decide how many you can afford to get or whatever. And you get as big a sample as you can get, as you can afford, your budget will hold, but you have what you have. And so it's not an option after you've collected the data to say, well, I want to go back and get more data. You know, that's not a valid approach to the inference process. The sample size really, in these lines too, doesn't affect whether our conclusion is valid or not. What it does affect is the power of the test. So those of you who teach the AP course, increasing sample size increases power. So you have a better chance of detecting a difference if there is one. So the fact that we were unable to declare 0.17 as being unusual, that doesn't mean it's not unusual. It just means that we weren't able to detect it with this particular sample size. So yeah, you'd like to have as large a sample size as you can get, but that's something you think about at the design phase, and once you've committed to a sample, you know, you're stuck with it. You only get one. I'd like to show just a real quick way to do the problem that Gloria was doing using Nspire. So there's if we think about what the process is, it's a yes-no population, and so it's binomial. So there's built-in in the Nspire and also on the 84 a random binomial command. I'm just going to type the command in. You can pull it out of the menu as well. She took samples of size 65 from a population that had 0.02, and I'm going to go ahead and pick 500 rounds of that. Each X on her distribution display just a second ago was one set of 65. So I'm looking at 500 sets of 65 bags, and we'll put those in there, and we'll call that num for the number of successes. And what we really want is the proportions. So what I need to do is to take those values and divide by 65 to turn them into proportions, and we can call that maybe prop. And so what we've got here then is a set of the proportions that she was getting. By the way, if you don't like having fractions sitting there, you can put a decimal in the calculation, and it'll convert those to decimals in your result. To see what we have then, and I'm just going to put it on a separate page instead of on the same page, we want to look at the distribution of the proportions. And I never cease to be amazed at the glob turning into that nice orderly dot plot. I love that animation. So anyway, we get a result very much like what Gloria got in her work. So I want to move quickly to another problem, and we'll only spend just a couple of minutes on this. The logic that Gloria went through is exactly the same, so we're not doing anything new here. In terms of the logic, what we're doing will be different from the calculation and technology side. So this is from the 09 Form B exam, and basically you've got a machine that's filling up juice bottles, and they're checking it to find out whether it's filling properly or not. They're looking both at the mean amount of juice that's dispensed. That needs to be 12.1, and they're looking at the standard deviation of the amounts that are being put into the bottles, and if it's greater than 0.05, so there's too much variability from bottle to bottle, then the machine is shut down and recalibrated. They assume that the amount of juice dispensed in the bottles is normally distributed. And away we go. So what we're trying to do, we're going to focus on the standard deviation calculation. And for those of you teaching AP stats and those not, there's, we don't have in the AP syllabus anyway a standard test for inference on standard deviations. So this is one you can go say, oh, well, let's go do a z-test or a t-test or something like that. We don't have that in our bag of tricks. So simulation is our only tool here. So in terms of the statistic that was observed, they collected 4 bottles. The mean was 12.05, standard deviation was 0.85. And again, we're only worrying for tonight about the standard deviation side of things. Go back to our previous, remember, 0.05 is our cutoff. And so what we have is 0.085 observed in our sample. And the same questions we talked about before. Is there any evidence that the population standard deviation is more than 0.05? Well, using the same logic we had a minute ago, 0.085 is definitely bigger than 0.05. So yeah, there's some evidence. Do the sample results provide convincing evidence? Well, now I have less feel about things. I don't know whether 0.085 is far from 0.05 or not. I don't have any experience with how standard deviations stack up. So how do I make that decision? So what we're going to do is do a simulation. And I think at this stage what I would like to do is, let's see, we need to figure out how to design our simulation. We said that the simulation has to come from the null hypothesis. So we're assuming the null hypothesis was the mean amount of juice is 12.1, that it's normally distributed, and that the standard deviation is 0.05. Those are all the things that were sort of what's supposed to be going on. And so what we're going to do then is build inside our Nspire something that has a mean of 12.1, has a standard deviation of 0.05, and is normally distributed, and see if see what typical behavior within that distribution looks like. So let me switch over to the Nspire and get us a new problem here. In fact, and we'll start with the list of spreadsheets page. And since what we're trying to do is to get a sample from a population that is assumed to be mean 12.1, standard deviation 0.05, and normally distributed, we can use the random norm command, the same command that you could use on an 84. 12.1 is the mean, 0.05 is the standard deviation, and 4 is our sample size. All of this is, again, was specified for us by a combination of the null hypothesis. The 12.1 and the 0.05 both came from the null hypothesis. The 4 is because that's the size sample they used when they checked it. And I'm going to call that 1 samp, just so I can remember what's there. I want to go ahead and split the window here. And over here, I want to put in a data and statistics page so we can look at the graph at the same time. And the only thing we have around right now is that sample, so we'll look at it. One of the cool things that I like about the Nspire is that you can look at repeats real easily. I call it the instant replay button. Control R or Command R if you're on an Apple generates another set of samples. I need to fix the window over here so that it's that we can see the values that stay in there. We know that we've got stuff that's 12.1 is the mean, 0.05 is the middle. So I want to go a few standard deviations either side. So let's put 11.9 as the minimum value and 12.3 as the upper value. That way we'll see our sample. And so I hit Command R a couple of times. What I see is a new sample generated real quickly. So right away, you can see the benefit, a benefit of using Nspire is that real quickly you can look at multiple samples and kind of see what's going on now. If we go back to the list and spreadsheets part of it, though, what we said we were interested in is the standard deviation of our results. So I can actually create a cell that does this spreadsheet type logic. So I can put STD, EV, SAMP. So again, what's there is the standard deviation. You can't see it real well because of the size of the font here. But it's the standard deviation of whatever's in the first column. And so that's, why did it not go? I forgot the equals mark, duh. Go to the beginning of it and put an equals mark in front of it. And it gives me a number instead of a bunch of words. That's better. Okay, so my random sample had a standard deviation of 0.08. The one in the problem had 0.085. And we're trying to figure out what's typical and what's not. In order to be able to do the next cool thing with this, you need to be able to store this. I'm going to get rid of this graph window, or I'm going to try to, so that we can actually just move it over a little bit. I want us to be able to see what's going on here. So in the form here, I want to name this cell. I'm going to call it SAMP SD for sample standard deviation. Sorry. You get in here. And you can do this through the store to variable command as well. Notice it's bold now, which means that it's actually recognized that it's been saved as something. And in column C, in the menu, there's a data command. And under that is something called data capture, which is, I think, the coolest thing on the Nspire, especially when it comes to statistics type work. We're going to choose automatic, and the variable we want to capture is SAMP standard deviation. So what this is going to do is going to take the value that I have over here for the standard deviation of my sample and write it down over here. But let me go ahead and name this so we can look at it later. I'm going to call this SD SAMP, SD distribution, SDSN. So that, remember the instant replay button. If I go back now and get a new sample, my sample in the first column changed. Here's the new standard deviation. I didn't lose my first standard deviation. I've still got it, and I've added another one. So if I hold down Command R and play instant replays, then I can generate this sampling distribution very quickly. So now that you see what's there, what I'm going to do is to go back over to my window here. I want to split this one more time. Where is it? I need my glasses. There we go. And we'll do another data and statistics page. And what do you think I want to graph? I want to graph the standard deviations distribution. Let's see. I'm going to set this window while I'm here. I need to set that from about 0 up to about 0.11. And the only reason I know that is because I tried a bunch of them before, and that's kind of where they fell. I don't know anything special about it. But now I can just sit down, especially on a computer. It's not quite as fast on the handheld. If I literally hold down the Control key and the R key, it just starts generating samples. And there's corresponding standard deviations. And boom, there's my standard deviation distribution, which I had no clue what it looked like before we started doing the simulation. And there they are. And the question now becomes, is 0.085 unusual or not? So I now have this tool. I can use the dimension command to figure out how many of these I did. What did I call that? SD underscore DSN. So there was 190. I did 192 samples. Let's go ahead and do 8 more. And that's how many I've done. And we can actually count them. I'm not going to do that right here, but there's a command called COUNTIF that says, okay, how many of these dots are there that are bigger than 0.08? The funner way to do it is to grab the scale and just go out here and count those suckers. There's 1, 2, 3, 4, 5, 6 out of 200. So 0.03 is my simulated p-value. So it looks like 0.085 is far enough away, and I probably do want to shut the machines down and recalibrate. Gloria?
Yeah, I'm here.
Okay. Let me see if I can get back to where I've lost my screen. Let me get this out.
Up to the top?
Here it is. No, I've lost my webinar screen.
Well, that's not good.
That's not good. It's gone.
Randy, do you want me to take control back, or is there something else you want to share?
I don't have my screen. It's gone. I did something bad somewhere.
No problem.
Now,
so before we begin wrapping things up, Landy or Gloria, was there anything else you wanted to add?
If I could have control for 30 seconds, I'll just quickly show how, if I can get, let's see, just a quick show and tell of how we could do something similar to this on TI-84. And what I have done is sort of set up the, what I would call sort of a home screen program that I could do. Notice that the first line here, I've set up a counter. So I've stored 1 to a variable C that I'm going to use as a counter. And then what we're doing in this instruction is there's that RAND norm, just like Landy did, 12.1.054. And I am preceding that with standard deviation. So when I execute this instruction, it's generating the sample of size 4 from this normal distribution with mean 12.1 and standard deviation 0.05, and calculating the standard deviation, storing then into the C element of list 1. And then it updates, this concatenated little colon thing, updates the counter so that if I keep pressing enter, what I'm doing is I am filling list 1 with sample standard deviations. Little bit less, a little bit more troublesome, I suppose, than what Landy did, but we can still do it. And if I'm patient and press enter rather than Control R, I can get 100 or so, and then look at a graph and make a similar conclusion to what Landy just did. Okay, that's it.
Mike, let me point out too that one of the things that you have, I believe, as goodies for the participants is a completed file that the TI-Nspire file, so that if they want to come back and look at it completed and deconstruct what's there, they have that.
Yes, sir.
Okay.
Well, as we begin wrapping things up, if there are any last-minute questions for Gloria or Landy, please try to get those asked. I know they'll do their best to try and get those questions answered. As mentioned by Gloria earlier tonight, we're really excited to have the T-Cubed International Conference coming to San Antonio in early March this coming year. Earlier, I think, Landy, you mentioned that we had 2 hours for tonight, and we probably could have taken 2 hours and expanded upon some of these concepts, maybe even in greater depth, asked some other questions, answered some other questions. And the T-Cubed International Conference, in my opinion, is one of the great places to do that. Usually we have a little more time at the conference than we might in just a short 60-minute webinar. So we hope to see everyone at the T-Cubed International Conference this year. Gloria mentioned again earlier that tonight one lucky winner will be receiving complimentary registration for 2 to the T-Cubed International Conference. And tonight's lucky winner is Jacqueline Solis. So Jacqueline, congratulations. We really hope to see you as well as everyone else at the T-Cubed International Conference.
Just one quick comment or answer to a question, because I'm, for some reason, not being able to send my response. The question was asked, do we have to be using a CE model? And absolutely not. Everything that I did with the TI-84 CE could have been done, perhaps no color, obviously, if you don't have a color model, but TI-83 Plus would have done everything that I did in just a little less pretty form.
Thanks so much, Gloria. To receive a certificate of attendance, go ahead and click that link in the chat window. Also listed is a link for the documents that were used tonight. If you happen to have an issue receiving either of those 2 links, have no fear, you'll automatically get a follow-up email within a couple days. And in that follow-up email will be a link to the recording, a link to the certificate, and a link to the documents. If you're watching this on demand, go ahead and copy that link down to your favorite browser to receive your certificate. Thanks so much, Landy and Gloria, for everything you shared tonight. We really appreciate everything.
It was fun for me.
Yeah, me too.
Thanks, everyone. We hope to see you back online real soon. Have a great night.